All right, so where was I? I was talking about the joys of technology, I think. That's you. I spend all my time with building technology, the Internet of Things, and consultant solution services. So I think that we're just going to be good to go running this presentation moving forward. The idea here today is mostly to talk about IoT architectures in buildings. There we go. So the general kind of overview for the presentation is going to be to talk about just two brief slides about who Schneider Electric is. That's the company I'm representing today. We'll spend a lot of time with what our world is becoming and essentially why talking about IoT platforms in buildings and connectivity and connected services is so important and is becoming more important over time. And then we'll move into what we call innovation at every level. That's how Schneider Electric puts together our products and services and applications to focus on that connected future. I do try to keep this as broad and general as possible so you can get kind of the overarching sort of macro trends in the industry, but a good way for us to do that is to talk specifically about kind of how we do it. And then in the last part, we'll talk about our partner channel and my team and some of the ways that we support the community. So we'll be finished by 1 o'clock. So we got about 50 minutes to get you guys back to where you need to be in terms of working on your jobs. If at any point in this conversation you have any questions, feel free to ask. I think that we've got a sign-in sheet going around. So part of that is like to send a PDH afterwards. This is eligible for PDH. Like to send a PDF of the presentations that you all have access to. And we are recording this specific one, so there should be that as well. So without any further ado, I'll get started. Like I said, just two slides about Schneider Electric. Some things that are worth noting. We're a really large national company, like a huge global footprint. We're actually based in Paris, France. Our CEO sits in Hong Kong to focus on some of the stuff that's going on in Asia. And we do just as much work as anywhere else in North America, where we all spend out. I think that's always important to note at the beginning of these presentations because the way that Schneider Electric has gone to market over the years is a little bit more split up, and we'll kind of explain how some of that has worked later in the presentation. But the name recognition of a Honeywell or a Johnson Controls or a Siemens in different territories that I go to kind of resonates more than Schneider Electric does. But that's changing with our EcoStruxure platform that we're talking about today. And the fact is we do have 142,000 global employees. We do about $30 billion of revenue a year, which I mentioned because 5% of that goes back into R&D. So that's about $1.5 billion that go into R&D. That's very, very important for where we're at. Just because hardware and software change so quickly, the BAS industry and what people are asking for and looking for, what your customers are requiring of you all is changing so frequently and so quickly in terms of smart intelligent services, connectivity and interface, all that changes. So we've got to put a lot into R&D. And then we actually have 6 vertical markets where we play. We've got 4 represented here to kind of simplify that. But buildings, IT data centers, smart grid, manufacturing, industrial processes, all of them have this platform sitting over top of it that consists of connected services and edge level and then apps, analytics, and services, just in the way that I'll explain buildings today. But the bottom line is we see a future where there's less separating these historically disparate silos because we're digitizing everything, and at that point, you can just easily connect between the smart grid in a building if you've got a customer that wants to condition their facility and then send PV photovoltaic out to the grid. So as we see that sort of merge, we're putting together these platforms to work together. So that's just an overview of what we do. And then within buildings, where we had that kind of highest revenue number that you saw, we've got lots of industry-leading brands that do different things within. So by show of hands, do we have any electrical engineers in here? Electricals. So Square D, electricals representing. Square D is a really big one on your end of things. Power Logic does metering for us. On the building side, if you think about access control and CCTV securities, we own Pelco, who's a camera company. Access Expert does cloud-based access control card swipe stuff for us. We can work with a company called Summit Energy to help us be more nimble and proactive in the way that we procure energy and maybe track that with like sustainability plans globally. Some data center companies, so APC does like on-prem, smaller data centers. MGE will work with huge data centers that we'll do for like a Waze or a Google or an Amazon or somebody like that. There's a lot of things that we have in here. We're going to spend the bulk of our time here today talking about EcoStruxure Building, our software platform for buildings, and how that kind of loops and ties all of this together with interconnected networks moving forward. So like I said, just 2 slides. I don't like to beat people over the head with, the company, but I think it's a decent broad overview to get us started, and then start talking about sort of what's driving all of our decisions in terms of R&D, the type of questions that we think you all are or will be getting from your customers, and where essentially building platforms are headed over the next 10, 20, 30 years. So I like to start by mentioning 3 macro trends that are happening in building technology. The urbanization of society, the continued electrification and digitization of society. So those are the 3. But I'll start with urbanization. So you can see here a lot more people moving into large city environments between now and 2050. 2.5 billion people is something like everybody in China and everybody in India, basically moving into cities between now and 2050. The constitution of where people live on the planet in 2050 is going to be 70% people living in large urban environments and 30% not. That equates to something like 3 million people every day moving from a non-urban environment into an urban environment. So it's a really, really big change in the way people live throughout the world. And I think often we think about that in terms of, all right, we're talking about the developing world and people raising their standard of living and moving into cities. But anywhere in the Northeast, in any city I go to, you see the same type of thing where people are moving back into cities. And they want like live and work and play environments. I think in Buffalo, like a decent example of that is it Larkin Square or something like that, where it's kind of like a trendy place that people are going to hang out. I'm originally from Pittsburgh. That's basically what all of Pittsburgh is. It sucked 20 years ago when I lived there, and now people are moving there, and it's being teched up. But really, anywhere you've got sort of these hubs that are centered on innovation. Secondly, talk about electrification. We're going to be using more and more electricity. Where we get that electricity from is going to change from sort of constant base load, the way we've always done it, to more of a decentralized grid. That's part of it. The other part of it is, as mechanical and electrical engineers and folks who are focused on commissioning and energy efficiency and stuff like that, we've always been focused on how do we make our building systems more efficient? How do we put together sequences of operations that help us optimize the performance of our facility, whether that be fan pressure optimization or chiller tower optimization or optimum start-stop. All of those kind of sequences have really always been stuff that we focused on in our community. And our governing body being ASHRAE with 62.4 and 90.1 and stuff like that is not really new to us. We're still really going to be focusing on energy efficiency. But I think the real big one, and why we're talking about the IoT so frequently, is just all of our lives are becoming a lot more digitized. Everything that we do today is much more digital than it was 10 or 15 years ago. The expectations that everybody has in terms of digitization are starting to bleed into the type of facilities that we design, and the expectations that people are going to have moving forward as they inhabit those facilities. So decent example for me that I like to use is just if I were here 15 years ago, I'm not from Buffalo, I don't know my way around, I would have gone to a gas station and bought a map and thrown it over the steering wheel and driven around and tried to figure out kind of where I was going. Now I look at that through an app on my smartphone. Digital interface, physical product that has been brought digital and then has different types of insights that you can get from it, like, hey, there's a cop half a mile ahead, or there's construction that you can't get from a map. So all of us are kind of growing with that expectation, and we're connecting more and more devices all the time. This is an exponential curve in terms of what we'll be connecting. Basically, as sensors get cheaper, and we can do more with that data and analytics. So these are 3 really big drivers for us for where things are headed. That said, I've got a slide here that focuses again on energy efficiency. I think as more and more services focus on occupant experience, and that is going to be something that's very important, we can't lose sight of the fact that the bottom line is we have to be really efficient in our facilities, and we still have a long way to go. So this report here says that about 80% of the existing building stock has unrealized potential in terms of optimizing what's going on there. not just green buildings. If we put, a greenfield design, if we build a new building, I think everybody's on board. We want that to be energy efficient. LEED and optimization. I think that I saw that you guys have a LEED certification here. But existing facilities that we come across all the time might still have pneumatic controls, might still have a system that hasn't really been commissioned in 10 or 15 years, and facility staff have sort of put things in hand over time and aren't quite sure exactly what's going on or how to use it. All too often, that's really what we see. So there's still lots and lots of potential in our industry to benefit sort of energy performance, optimization, and efficiency. I don't want to shortchange that. A lot of what we can do with IoT platforms and buildings is still going to focus on energy efficiency. I preface that way because this slide is one that I spend a decent bit of time on in this presentation because I think it's a newer paradigm for us in this industry. So I was just talking about energy efficiency. I think all of us have spent a lot of time and energy learning about that and focusing on that and providing that for our customers. But there's a new sort of paradigm, a new way to look at buildings that's come up a lot recently. And I'm not sure if anybody here has seen this. It's called the 1990 principle or the 330-300 principle. Ring a bell to anybody? Has anybody seen this? A lot of times it's something that I think we hear about when we talk to developers and end users. But essentially, in broad strokes, it's focusing us much more on occupant experience in facilities. And the reason for that is where that 1990 comes from. So you've got JLL here at the bottom. There's a couple other developers that have looked into this. Essentially, what they'll say is, I'm going to build a 40-story building somewhere. My task is I need to lease out all of these floors for the longest period of time to the highest profile customers that I can. So how am I going to make sure that I can get that high profile customer to occupy the 8th floor of my facility? And what they've done is put themselves in the shoes of the people that will be leasing out that space. And what you can determine is really the annual costs that those folks will undergo are really much more focused on the people in that space than they are in what they pay for their lease to be there, or what they pay in terms of the utility bills and keeping things under condition and lighting. And here's how that works. So basically, they're saying within that space, people are represented by salary, benefits, productivity, paid time off, sick leave, all of those things. They're represented by do they want to come in early? Do they want to stay late? Are they happy and productive throughout the course of the day in terms of just straight up productivity? But you could also look at that as the workplace and workforce gets more competitive. Can I use my facility to attract better talent? Can I use my facility as a recruiting tool to keep talent here longer so I'm not constantly going back out, rehiring, retraining people, and doing things like that? Can I use this facility as another feather in my cap as an employer to keep the best talent? And what they see is that really that's kind of where a lot of that spend goes. And the biggest thing you can influence is the bottom line and what we're all here to do. So we're all currently occupants. We're paid to produce. How can we be best able to produce and bring our best selves to work? It's sort of a newer concept when you talk about things like technology, but if you think back to like startup communities or Google and Apple and all that stuff, they were really early in this in terms of providing like foosball tables and hanging chairs and coffee shops and stuff like that to get talent earlier. But now it's moving much more towards looking at where the workforce is headed and embracing technology. So millennials is bolded here because it's a politically charged word that gets people all fired up. I think this applies to everybody. I mean, all of us like to have Wi-Fi connectivity and the internet and stuff like that, but millennials are known as kind of the first generation to grow up with technology where it's very, very important to them. I'm a card-carrying member myself, and I like to say that I like avocado toast and kale smoothies and all the obnoxious things that go along with being a millennial. So I can speak to the fact that technology matters to me. But I think another thing that's really interesting is, as a millennial, I can remember when my family first got a computer. Like, I remember the world without the internet. I think I was like 10 or 11 when we got a computer and dial-up and all that stuff. If you were born in the last 10 years, you've never known a world without an Apple iPhone or a smartphone. So if you're 10 years old today, you're in college in 8 years, you're in the workforce in 11 or 12 years, the only thing that you've known the planet to be is electricity and running water and high-speed internet connectivity and smart devices. So really, when we put together building platforms today for a customer right now, we can expect those BAS platforms to be there for 30 years, 10, 20, 30 years, however long we see them. And we need to start projecting out who's going to be in that facility and how they're going to interface with that space. So a big driver for what we're doing is really focusing on this IoT platform to sort of embrace what those expectations might be moving. So really, the crux of this slide is just to think more about occupant experience and how we can maybe make forward, because a lot of people are starting to look at this. So what might that look like? I mentioned sort of IoT connectivity. Another really annoying kind of buzzwordy term is disruption and disruptive. But this does give us a nice overview of what we might be able to expect from building platforms moving forward as they're connected, because we've seen so many industries already be disrupted by technology. It always looks something like this. So if you think about that annoying word and any type of industry, you can see this being replayed over and over. So one thing I like to mention is like the music industry and record labels and things like that. And we all used to have tape collections or CD collections and iPods and stuff like that. Ultimately, that has been replaced, and the largest revenue generator in the music industry now is streaming music services like a Spotify or Pandora. From your mobile phone, you can access any song that's ever been produced via the cloud. The service senses what you listen to, runs some analytics on it, and then says, you like Taylor Swift, so you might like Rihanna or something like that, right? It makes that experience a lot better for you. And in all of the cases, that's really what we see. So you can go down the list. Lyft and Uber are a great example versus the taxi cab industry. Amazon Kindle, is that what it is? The Kindle? Yeah. Is a great example. I still like physical books, but you could take your book collection and have one mobile device that has every book ever. You bought this, you might like this. Over and over, we see that. So we feel that as more building platforms are digitized and connected, we'll see this in buildings. And we're already seeing some of this in BAS. So a really good place for me to kind of introduce one of the places we've seen this in sort of a concept is automated fault detection and diagnostics, which, have you guys heard that term or used it or spec'd it or anything like that? So an overview of how you could look at automated fault detection and diagnostics is basically there are services that can connect to a BAS system. So any BAS system can be connected to a cloud-based fault detection service. And for example, ours is called Building Advisor. You can connect to every single point within that facility. So temperature, valve or damper position, any of that stuff. Send that information up to the cloud and present it against a digital twin that shows you how the building should be performing in optimal, perfect scenarios. And then measure what is actually being seen on site versus what was expected via design. And then send that information back down to a facility manager or to a service contract provider to allow us to be more proactive in how we address service issues in terms of energy cost abatement or potentially large service issues that might be coming up, or just straight up occupant comfort. So it's like an added level that's augmentative to what is happening at the field level for BAS. And it looks a lot like this: cloud, sensing, analytics, cybersecurity. So that's just one example of how this is being prepared, and I'll show you a tech stack moving forward that illustrates how else that could be applied. But we're already seeing it happen, and it's why sort of thinking about the Internet of Things is important when we design platforms now. So with that, that's sort of the overview of kind of why we think this stuff is being important. And now we'll get into a little bit of how to go about doing that. At this point, are there any questions in the room? Is anything stuck out? We can make a note also for a follow-up presentation that's on our automated fault detection and diagnostics platforms and how we could go about doing that, if that's of interest to you all. But figured I'd open it up for that. No questions? I'll move on. All right, so I mentioned our tech stack. So I think that this is probably the most important slide that I have in the presentation in terms of kind of understanding where we believe the industry is headed. So what you see here is a building automation slide. And if I were here 5 or 10 years ago and I were presenting a BAS system, you might have seen kind of like one line at the top that is kind of your IP, internet connectivity, 100 meg. You'd have your computers, smartphones, servers at the top, and then you have a bunch of lines running down to field devices, similar to what we saw in the BAS 101 presentation. Those lines represented BACnet over MSTP, which is how all buildings are essentially connected now if they have BACnet. They communicated a baud rate. So there's data being transmitted through that field bus at 76.8 kbps. It's not very fast, but it's good enough for what buildings have done. What's happening is with the tech stack, we're kind of re-envisioning the way that buildings work. So what used to be at the top level, that operator workstation, is now at what we call the edge layer, because we're connecting with field devices now via BACnet over IP. So as opposed to that baud rate I mentioned before, we can connect to field controllers with Cat5 or Cat6 cable at 100 meg. So whatever your internet connectivity is at your home or your apartment or something like that, which gives us an immense amount of bandwidth at the field level between all of our controllers. It's about 1,000x or 1,200 or 13x more bandwidth than what we see with BACnet over MSTP. And it's a huge thing that's happening in our industry. So we're one of the leaders in doing it, but I expect that you'll see, I'm sure that you'll see really everybody make that happen. Joel likes to kind of compare it to going from pneumatic to digital controls is really similar to going from digital MSTP to digital BACnet over IP, just because of what it's going to free us up to be able to do. And so what that is really a world where we're going to be interfacing with our systems much more via apps, analytics, and services. So we can build services and apps and analytics on top of our platform now because we have so much more bandwidth and connectivity. You can think of it almost like what happened with smartphones. As soon as we got smartphones and could connect all of that sensing data and information, developers were able to enter the field and start creating apps that made that platform much more valuable. So all the things that are on your smartphone, which looks a lot different than my smartphone, are typically generated by developers that have come into the field and not by Apple or Google. So we think that the Schneider Electric EcoStruxure IoT Internet of Things platform is really going to be a jumping off point for lots of third-party connected products, third-party connected systems, and third-party connected services, where people will enter the space and figure out new ways that we can use, which is really, really exciting. You can start thinking about buildings with a smart platform approach. So I mentioned Building Advisor. This is our fault diagnostic platform. There's a lot of things that we could talk about in terms of others that we personally are building. And then you could also kind of anticipate that more and more people are going to be coming up with smart ways to use all of this data and information. And then once they do, it can get a lot more specific to customer end use cases. So we don't have to just be wondering and worrying about kind of the chiller plant and the boiler room and kind of just temperature. We can start affecting the business use cases of all the different vertical markets that we're in. So a decent example is healthcare. A smart operating recovery room of the future could have a tablet at the patient's bed where they can adjust the lights, adjust the temperature, adjust the bed, call the nurse, Skype their family, all that stuff. So you have this sort of integrated solution of the future where we're actually a part of making that better. Hotels, there's an example that we have up in Andover where we've put together a mock-up of a hotel room where you can go in and speak to an Amazon Alexa and say, Alexa, it's time for bed, and it will close the blinds, turn off the lights, and set the temperature to whatever you would have like in your Hilton Honors app or something like that, so that we can kind of help them compete against the people that they go out against in their industry. So we expect more and more niche analytic application services that will help all different types of customers that we might have. And that's why I think this is like such an important slide. It can help you sort of contextualize the fact that we're moving to this edge control layer that allows us to focus on all the things that are happening in the field, but gives us a huge pool of information to build applications and services forward. We think that that's going to be pretty cool. What that might provide for us are smart buildings. So smart buildings as a term is sort of in its early days. I always like to compare it to green buildings and LEED whenever it first came out, whenever that was 10 or 15 years ago, and there was a lot of confusion. People got really frustrated. They didn't know how to say this was a LEED design or a green building and all of that stuff. I think that's really where we are with smart buildings. So we're coming up with you know, the early cases, and we've got some case studies and cited reports that show some of the benefits that you could have if you have a smart building. And there are services that are being built around smart buildings. So there's well building design. There's wired score that focuses on building connectivity that allow you to kind of say this is a smart building. What we're seeing are energy savings, things like less maintenance costs. And so less maintenance cost, a great example of how you get less maintenance costs is if you have that smart platform, you have an analytics service that runs off of it, you might be able to remotely connect to that facility and make changes if you've got an alarm at the facility remotely from your office, as opposed to rolling a truck out there, sending somebody to the site that might not have the right tools or something like that. Those costs really build up. You can be smarter, more proactive, and more preventative. Space utilization is an interesting one too. There's an advisor platform and really a whole industry that's being built right now in terms of like footfall traffic and understanding how people are using facilities. So you can start to get insights on where might be the best place to put a coffee shop in a building, or if you are a large building owner and you've got a building that is 15 stories tall, you can see that the 7th floor and the 14th floor are always half occupied. You might be able to go to those companies, sweeten the pot, put them on the same floor, and open up another floor for you to kind of lease out and generate more revenue. So footfall traffic and workplace space utilization is really kind of heating up. And then you get into, again, comfort and productivity if you think back to 1990 and why that was so important. But I think that this is kind of cool too. We're seeing additional rental value if you have a space that you could say is smart, and then ultimately a premium on building price. If you're an owner that building say is smart or has appropriate wired score or wellness score, it actually does have benefits on the open market. People are moving into these spaces and are interested. So those are some benefits of smart building. Now, how we go about doing it at Schneider Electric and start looking at some of operating platforms. Talking primarily today about our building automation, building operation platform, but there are other things that I'd like to share with you all so that you're aware. We have a platform called Building Expert that is for small buildings. So if you have something that is under 100,000 square feet, or is more of a light commercial application, maybe a strip mall or something like that, or a tenant fit out in an old building, or even a historical building, Building Expert is a pretty good idea because we can do wireless communication via the Zigbee protocol between all of our thermostats and controllers and rooftop units. So have you guys ever gotten in any of that stuff? Wireless controls? Any of your customers ask for that here and there? Just something to know that we have, and if you have an application like that, John and Kyle could price that up and take a look and see if it's beneficial to look on that end. I have a counterpart that covers this area named Ralph Beaudry. He could come in and give a full presentation on what that platform looks like. We have other kind of platforms that I'll mention here. Power Monitoring Expert is our big heavy-duty platform for the electrical side of things. Power factor quality, all that stuff, the whole kit and caboodle for our solutions. I'll also introduce later in this presentation a way that we can sort of stream monitoring information, whether that's water, air, gas, electric, steam, into BAS through our Energy Expert. We've got Access Expert I mentioned before for access control. Video Expert allows you to see kind of what your cameras are doing. But generally speaking, what that gives us is a holistic view of anything that you could kind of look at or control in a facility. This slide is really important for me to share with the engineering community, and I kind of hinted at this when I got in here with sort of branding has not been a strong suit for Schneider Electric for a really long time. And part of that is that what Schneider did is over the last 10 or 15 years, we bought a bunch of different BAS companies. So some of these might be more familiar to you or you've seen them here or there. So you'll see Andover Continuum or Invensys or Barber Coleman. All of those companies were purchased by Schneider Electric, and then sort of the best practices from each of those platforms were put into consideration, and our EcoStruxure platform was built. So this is our system moving forward. You know, any new building would be EcoStruxure by Schneider Electric, UNS Services if you would like, to kind of specify who you'd want to use that system. But our new systems, this IoT platform, IP-based field controllers is EcoStruxure. That said, every single one of these platforms that's over here to the left have an active transition path. So if you find a customer that has one of them and they'd like to get to new systems and facilities, there is an active transition path where you don't have to take every single thing out. You can build moving forward, you know, stepwise. As those controllers fail, replace with EcoStruxure field controllers, that kind of thing. We didn't want to leave any customer behind. And then on the far end there, you see a bunch of sort of life cycle, clean, green design things that really play well right now in Europe, but that will ultimately, I think, become more and more important over here. So those are some kind of, you know, that stuff on the right there I think is kind of cool to note. Another thing that's always worth talking about in these discussions is cybersecurity. As we talk about more connectivity, we talk about the Internet of Things, connecting different devices and IoT platforms. The traditional Achilles heel for that is always cybersecurity, and that's not going to change. Moving forward, that's going to remain this evolving threat. That's not something that I'm going to come in here and say, we've solved, you'll never have to worry about this again. For a lot of reasons, there are people that are hacking facilities and trying to get into systems. And it's something that we've seen for years now. So anybody that you work with on the BAS end of things, as you look at IoT platforms and connected devices, really vet them strongly in terms of cybersecurity. I've got a lot of things here that focus on the type of stuff that we do. Not mentioned here is, I don't think, is a group called C4 that are cybersecurity experts. So they are not BAS people that learn cybersecurity. They are cybersecurity dedicated folks that are now on board with Schneider Electric. And they'll go throughout the country, often working like with military bases and stuff like that, do device hardening, do consultations to how to make your system more cyber secure. And they'll also hire like benevolent hackers. So for a few days, they'll have hackers come in, try and figure out what they can make happen in the system by breaches and things. But every time we have a software revision, we're incorporating best practices and new things. That's real fancy. There's also stuff like having secure emails and password policies. Unfortunately, that's just as easy of a way to breach a system as anything else. You guys do a really good job. I had to get my USB here scanned before I was able to put it onto your system. So kudos for that. But all those kind of easy things need to be incorporated into cybersecurity policies as well. Another presentation that I offer is a CEU qualifying 1 hour long discussion of cybersecurity in buildings and sort of a defense in-depth strategy, where we've seen like really famous breaches in the past and some of the things that you all could do to potentially shore up your specifications in terms of cybersecurity if that's to you all. Next, we've got graphics. You know, what's important to mention about graphics for any control system that you're working with is that it's something that the facility managers or whoever's using it like, so that they use it and are not trying to avoid it. The more they use it, the better they'll learn it, the better they'll utilize some of the best practices. So we like to say that ours are simple, intuitive, and versatile. And the two things that I typically highlight are that we use scalable vector graphics, which in today's day and age really matters because you'll have a facility director or business planner or whoever accessing the BAS system through their smartphone or through their iPad or through a really large computer screen. And we want to make sure it looks the same in all of those circumstances. And that if you zoom in on a part of the system or a piece of equipment, you don't have some degradation of quality in what you're looking at or pixelation or anything like that, which sounds pretty standard for where we are in 2018, but with control systems that are older and more legacy, that's not like a guarantee. So we do like to mention that that is part of what we do. We also use HTML5. There's a couple benefits to doing that. Java is a third-party plugin, which creates an unnecessary cybersecurity vulnerability. But also, our customers don't always update Java. They call and they're upset because graphics. Java, not actually BAS, so we kind of cut that out by using HTML5 for our graphics. But again, you just want to make this simple and user-friendly, really like any other graphical user interface. Previously in this presentation, I mentioned this software module service that we offer, kind of in line with how we think that there's less separating historically disparate trades, historically disparate portions of building technology in a facility. We've put together this program here that's embedded power and energy management, something that you could specify today competitively if you'd like. But essentially what it will do is we can use Modbus to any of your metering devices, whether it's air, gas, steam, electric, water, anything that's being metered. We can run to those meters, pull that information into the BAS, and we have a pre-purposed software module that will show us how we're performing this year versus last year, how one wing of the facility is performing versus another wing, so we can do some tenant metering and things like that, and really give us a feel for resource consumption and allow us to dashboard that as well, which is often becoming more and more of a requirement. How do we share this with the community, what we're doing? How do we report, this year versus last year, that kind of thing? And really give us a bit of a high-level overview for the electrical performance through BAS in a single pane of glass in a way that is non-standard in the BAS industry. And if you wanted to do it, you'd have to kind of really do a lot of programming and labor-intensive stuff. So this is something that, as a follow-up, we could share with you all if you'd like to learn more about it or specify it. Pretty cool software module that we offer. Those guys are having a lot more fun than us. Sorry about that. I've got a couple slides on hardware, essentially to share sort of how we're enabling a lot of these cool things that we're talking about. What I'm showing here is our network server. So basically, one way to think about this guy is it is the interface between your building system and the graphical user interface that all of the facility managers will use to see it and do scheduling and trending and handle alarms and stuff like that. It all goes through this network controller. So we'll run communication buses from the automation server down to all of the different field controllers that we have, whether those are VAV boxes or air handling units or chiller plant, what have you. And there are some really important things to note about this ASP. Two in particular. One is it has dual Ethernet ports. So all network controllers already have one Ethernet port. That's how they've always sat on that top line that I mentioned previously. That second Ethernet port opens us up to run that Cat5 cable to all of our field controllers in the facility. This allows us to have that platform, that robust infrastructure to build off of moving forward, so that when your owner comes to you in 9 years and says, this new thing's been invented, I'd like to pull data from the system, you have that platform in place, and you don't have to worry about saying how we can do that. And then the second thing to mention here is that it's a communications hub. So historically, in our industry, the very first control systems were proprietary networks. So legacy Schneider Electric systems had their own proprietary network. Johnson Controls had a proprietary network, Siemens proprietary network. And then we moved towards BACnet and LAN and these more open networks. We're at a point now with this automation server where out of the box, we could run a trunk off of this controller that is communicating BACnet and another trunk that is communicating LAN. So if you have a facility that has LAN, you could run a trunk from here that communicates LAN, and then everything new, you can do BACnet. You can communicate Modbus out of this. You can communicate web services, so we can bring in information like energy pricing or weather information, and all of that stuff. And then really, really importantly, we can connect via our smart connector to third-party applications and services. So really, what Smart Connector allows us to do is, I mentioned that Amazon Alexa before. Amazon Alexa does not communicate via BACnet. They have their own way of doing things. We take the Amazon Alexa, we build a Smart Connector, and then we supply that to the building automation to grow what we can do with third-party applications. It's almost like SDK for like the App Store on your iPhone. And so I mentioned Amazon. They're obviously the biggest company ever, but this could be a third-party developer that comes up with an app somewhere. We could build a smart connector to connect to that service and make it part of what's happening. So really the idea here, out of the box with no annual licensing fees or anything like that, out of the box this thing comes with the idea that we are meant to be speaking as widely as we possibly can. We want to be as open as we can be via a hardware perspective with the ASP. And then that dual Ethernet port is going to run a Cat5 cable to our field controller. So we have our IP-enabled field controllers. Basically, we just match the point count to what's required of that piece of equipment. There are 7 and 9 point count field controllers that are for VAV boxes. There's 15, 18, 24, and 36 that are just applied to fan coil units or chiller plants or whatever. And then we run that Cat5 cable to those. And the benefits that you have are data collection, which I think is really the primary thing for how buildings are going to change moving forward, but also cybersecurity assurance with all of the things that are built into what I mentioned with our C4 team and the way that all of our software revisions incorporate cybersecurity each time. Not mentioned enough are things like industry standards for IP-based protocols. So as opposed to trying to find an issue in a network that's communicating over MSTP, which can take a long time because it's hard to tell where that breach happened and why, we can now ping networks the same way that IT professionals in a facility have done for years and really quickly understand where we might have an issue with the network, what needs to be addressed, and get that resolved very, very quickly, saving time, labor, headache, downtime, all of that stuff. And then lastly, we've got much greater architectural design flexibility, which leads me into this next networking slide. What we've got depicted here are ways that we can run that Cat5 or Cat6 cable to different field controllers throughout a facility. We've also got in the top here that this can be done on public and or private IP networks. So really, we're going to have a lot more conversations moving forward, and I believe that you probably have, with IT personnel way earlier in the process for all of our projects, where they're going to be at the table working with facility folks to determine IP drops and communication ports and all of this stuff and how this system might interface with their facility and how they might like to connect with this different systems. So if there's one takeaway from this presentation, I think a lot more of our sales and service and installation offices are going to have more resources in terms of networking and IT background people. I think more engineering offices are going to have that. And I think in many of the projects that we have moving forward, there's going to be much more dialogue involving IT folks than there have been previously. A lot of times that's kind of towards the end and creates a little bit of traditional friction between facilities and IT. What you see here in terms of network flexibility are just different ways to run that Cat5 cable. So here you've got a daisy chain. This is how we often run MSTP today. It's just in and out of every controller. This is beneficial if you're looking for a lower cost installation. So if you've got controllers that it's okay if you lose connectivity to them for a while and they just go to standalone, you might use daisy chain. Let's say there's 30 controllers on this trunk and you lose the second controller, you actually lose everything downstream of it, so they would all go into standalone sort of communication to the spaces that they serve. You might not want that for laboratory settings or really, really important things, so you can home run and do redundant cabling with this approach here in the middle. And then on the end, we've got a ring topology. So more or less what the ring topology will do for us is we can hit every other controller on the way out and then every other controller on the way back, so that if I lose this controller, which is the middle one for the people on the WebEx that can't see what I'm pointing to. If I lose the middle controller, I can still connect to everything upstream and everything downstream of it, and I just lose that controller. So it's a nice sort of hybrid approach. We'll probably get to a point where we're specifying the way wiring is run in facilities, and there might be different parts of a facility that are wired in different ways. Some parts that are okay to daisy chain, other parts where ring topology, because there will be just like a labor component to that. So that is it for products and services, how we go about doing things. There's about 5 minutes left, which is good for us to talk a little bit about how we go about servicing the market. And that always starts for us with our partner and branch channel. So Schneider Electric has 185 partners throughout the United States, and we have, I think, 14 branch offices. Not a branch in the Buffalo area. You're serviced by third-party independent businesses like UNS Services, which is really, really important and very beneficial for how we go to market, because all of those partners are people that we've had relationships with for years. In many cases, decades. It's not like a fly-by-night, over-the-counter type partner arrangement for third-party distribution. It's really a mutually invested relationship where these guys have to go through all sorts of training. They have to meet all sorts of standards. We have to provide them with all sorts of new updates and stuff like that. It's a long-standing partner relationship. What that means for any market is, in the idea of things being open and not being sole-sourced and locked in, and a lot of things that customers will come to you for, it allows for a peace of mind because every territory is serviced by several partners that Joel manages. That's why he's here today. Muscle. Yeah. So basically, customers have the peace of mind when they get an installation that there are other reputable partners that ultimately, if push comes to shove, could service that system. Now, by and large, that doesn't happen. UNS Services supplies and installs a system. They service it over time. The customers really like them. But part of that is because there's other partners. So you need to protect those relationships, provide high-level service, and it allows us to kind of have this sort of open method in a market. So if you think about a spectrum of completely closed to being wide open, you might have some big, large company that's the only show in town for that system. Once they're installed, you're stuck with it. Doesn't matter if they decide to charge you whatever for service. Doesn't matter if you don't like them, all that stuff. The other end of the spectrum is something that you could say, anybody could use this tomorrow. I could learn how to use this and supply it next week. Thousands of people in the market can do it. The issue that you run into there is that doesn't mean that they're reputable installers. Doesn't mean they're going to be in business in the future. There's a lot of issues that way. This kind of gives us a nice spectrum there. Peace of mind for the customer, and also reputability and capability in terms of working with our stuff. That's really important to address and help people kind of understand. That's where UNS comes in. My group that I am part of is called Proficient Consultant Solution Architects. I will send a link to this platform afterwards. That is an online repository for courses or white papers, data sheets, case studies. I think I mentioned training that you could access whenever you'd like. Friday night, you've got a glass of wine, you want to learn about controls. You don't have to send me an email. You can just go to this platform and do that. So I'll send a link to this. Our goal and mission is to support the engineering community in our regions, to learn from the things that you guys are hearing from for your customers, to share with you things that are changing every couple months or every few months, to talk about big trends like automated fault detection or cybersecurity or the Internet of Things. We're looking to sort of be a plug-in for our on-the-ground partners. That's what we do. One of the things that we've generated is it's now called Spec Designer. It was called Spec Writer. I've got to change that. But essentially, you all could access this tool, answer a few questions about kind of the name of the project. If you'd like to do BACnet over IP for field controls, just some basic questions. Company needs to be within 50 miles, that kind of thing. And it will generate a Division 23 spec for you. in a Word document. So you get a 23 spec, and then you could alter it however you'd like. You could say, I'd like Schneider Electric EcoStructure. You could remove us. I think that would be rude since we gave you the tool, but you could. So it's a tool that a lot of people have been using, and I'm happy to send you a link to that as well, and I'm sure these guys can come in and show you how to use that. And then, the last slide that I've got here is just third-party validation for some of the things that we've done. We're up and to the right, which is where we'd like to be in terms of kind of execution and vision and all those things and strategy. One thing I always like to note is that IBM is on both of these, which I think is cool. It lends some credence to what we're talking about for the Internet of Things and analytics, because IBM is on a hunt to find big pools of data that they can use Watson AI analytics on. Now that buildings are opening up with this IP infrastructure and connecting more and more systems together, they're starting to enter into the field and try and figure out what their smart building approach might be, which I think is really neat. It kind of shows us where things might be headed for BAS. I've got one last slide here that just says, hey, here's why you would specify EcoStructure for an IoT platform with analytics. As I said, I'll be sending this to you all, so I'm not going to read through it exactly, but the high-end thing for me is customer experience and outcomes. You're going to be able to be a lot more nimble and proactive on that front. So with that, that's the discussion. That's the presentation. I thank you for the time. The next steps, I'll be hanging out for a while if you'd like to talk about anything in particular. I will send the follow-up email with the PDH. We'd love the opportunity to come back and chat with you about something else in the future. But these guys from UNS are happy to also come through and support you however they can. So thank you. I appreciate it. WebEx people, thank you as well for listening in. And we'll be around. All right. Take care all. Thank you.